Should nutritional requirements be redefined for astronauts during space missions? This is today's topic. It's very important, and it seems that some of the main health problems experienced by astronauts when they go in space and when they come back on Earth mimic some typical chronic diseases that affect people on Earth. So addressing these issues and finding solutions is very important for both astronauts and us. Yesterday at the University of Toronto, there was a very interesting presentation of Dr. John B. Charles. It was March 23, 2018. Dr. Charles is the former chief scientist at the NASA Human Research Program. The event was organized by ASX, Astronomy and Space Exploration Society of the University of Toronto. I thank them both again. The presentation was very interesting. Dr. Charles covered a wide variety of topics, and he was also very generous and patient in answering all our questions, also for a long time after the presentation. He talked about how NASA is preparing long-term deep space missions, especially to send people to Mars. And then he covered the main health problems associated with these missions. Very quickly, because I don't want the video to be too long, NASA divided these projects in some main steps, phases. Now, what they're doing is what Dr. Charles called a phase 0. It's mainly brainstorming to identify all the problems that will likely or might happen and find solutions. When they will feel confident to have found the problems and the solutions, then they will go through the next phase. They will start sending materials and working on the moon as a kind of a pre-mission and preparation, and then they will send equipment, supplies, and then people to Mars. At the moment, NASA doesn't have any plan to colonize Mars permanently, just to organize back and forth missions. Well, it's a huge job. Elon Musk from SpaceX, on the contrary, intends to colonize the planet. We wish both of them all the best, and we hope that they will succeed as soon as possible, both SpaceX and NASA. So going back to health problems, there is a wide variety of typical conditions that occur in astronauts. I will summarize the topic because it's huge. The main, and the literature behind this is also abundant, but here are the main problems. For example, from a nice article written by Ivan Semenyuk, The Globe and the Mail, he summarized some results from scientific research. Chris Hadfield, for example, at the University of Waterloo, showed that astronauts have experience a metabolic impairment similar to someone on Earth, some common people, that is developing type 2 diabetes, which means elevated insulin levels and blood glucose levels. Now, this is bad. I hope I will have time to record other videos specifically on this topic of glucose and insulin, because it covers and it touches many other aspects of human body and health, and many other diseases too. But in a few words, having high insulin and glucose levels affects everything: cardiovascular health and performance, brain health and performance, mood, concentration, inflammation, allergies, autoimmune disease. It affects many other things. And another problem, of course, is with bones. There is a very fast bone demineralization, a decrease in bone density. I was shocked by the words used by Scott Smith, manager for nutritional biochemistry at NASA's Johnson Space Center in Houston. He says, I quote, sorry, it's like doing time-lapse photography. When analyzing the bones in astronauts, their decline, their change is what you see in an ear in postmenopausal women. Again, going cardiovascular, there is stiffening of arteries, which is also unwanted, also when it comes to performance, besides health, of course. Also, University of California, Irvine found that astronauts may face long-term brain damage as a result of space travel. And then there's the problem of prolonged isolation and confinement. For example, German researchers who spent more than a year at South Pole on a research trip, according to a study of the Center for Space Medicine in Berlin, led by Alexander Stahan, experience brain shrinkage in the regions related with working memory and decision making. So we're talking about brain shrinkage. I mean, it's not a joke. And also, memory and decision making is crucial when it comes to space missions. Now, if this happened, sorry, I forgot to mention, also they experienced a decline in brain-derived neurotrophic factor, BDNF. What is this? This is a molecule that is produced in our brain. It's important for neurogenesis, for neuron formation of connections between neurons. It's important for health and performance of brain. We know that BDNF production is favored by physical activity. Now, just because of isolation and confinement at the South Pole, those researchers experienced a decline in BDNF levels. Imagine in space. In space, there is both isolation and confinement and decreased, if not zero, gravity. Now, zero gravity means much less physical activity and exertion. So one more reason to lack BDNF in their brains. I was looking forward for an event like the one that they held yesterday at the University of Toronto since 2014. Why? Because I was studying food science at Centennial College, and I prepared a research proposal called Optimization of Food Rations for Astronauts, July 2014. In this report, in this research proposal, I covered some of the main health issues that astronauts experience or I suspected might experience, such as a decline in BDNF levels, and possible solutions. That's what I would like to mention too. Quick potential remedies and solutions that are easy to apply, even by us, by common people, with products that are available to everybody and safe. So we covered some of the main health problems, and now let's go to the possible solutions. Why? We all know the concept of essential nutrients. What are essential nutrients? They are nutrients that our body needs to receive with food because it cannot produce them, like vitamins, some amino acids, some fatty acids like omega-3 fatty acids, and minerals. Now, on Earth, in normal conditions, the guidelines and the recommended daily intakes of these nutrients are very well, nicely defined. There are guidelines, there is a long-term science behind them. However, there are a lot of other compounds contained in food, in plants, that showed beneficial effects on many aspects of human health and performance, many different organs, but they are not essential. Why? Because our body, under normal conditions, can produce these molecules, so we don't really necessarily need to eat them. And the benefit of supplementing these products are variable. One of the main reasons why this happens like that, in some cases they help, they produce benefits, in other cases they don't, or they do but at a more limited uh, extent, is because sometimes there might be other factors that increase our needs of these compounds. For example, let's take taurine. Taurine is an amino acid. It's not an essential amino acid because our body can make it. But taurine showed very important beneficial effects on glucose metabolism to help the body to control the glucose level. Speaking of which, insulin metabolism, insulin resistance. So taurine increases insulin sensitivity, which means that the body needs less insulin to achieve the same control on a given level of glucose. It also has beneficial effects in our brain. It increases the formation of neurons in the areas involving learning and memory, which are exactly the same areas affected in the studies that we mentioned by isolation and confinement, and most likely also by space missions. Now, if a healthy person that is not undergoing any particular stress, is young, it doesn't have any disease, takes taurine, probably it's not going to make a big difference because this person is already healthy, doesn't have any problem. But if a person with brain shrinkage, like an astronaut or a researcher at the South Pole, takes taurine, well, I wonder, it might be very beneficial. Now, usually the studies that showed positive effects of supplements showed that these happen especially with people with health conditions. For example, old people, patient with brain disease, with Alzheimer, they experience a more pronounced beneficial effect of this or this supplement compared with healthy young subjects. But if there are similarities between health issues on Earth and health problems experienced in space, it is likely that these compounds that show positive effects on people with health diseases on Earth will also help astronauts in space. We are talking about plant extracts, amino acids, particular forms of minerals. For example, magnesium. Magnesium is very common. One could say, well, astronauts bring freeze-dried fruits, vegetables. There are plenty of products containing magnesium foods. But studies showed, for example, that magnesium L-threonate, which is a form of magnesium combined with the threonine amino acid, is able to even increase the BDNF levels in brain, and it's much more easily absorbed and transported into the brain and more quickly. So there is a lot of science behind natural supplements, nutraceutical compounds. Another advantage of these products that is worth mentioning, especially when it comes to space missions, is the long shelf life of these products. we are mainly talking about dried products. When we dry something, we remove the water. This gives a lot of advantages on Earth and especially for astronauts. Why? Because if we remove water, we decrease the weight, the mass, sorry, of these products dramatically. If from 100 grams of a plant, for example, we dry this plant and the mass decreases from 100 grams to 10 grams because maybe 90% was water. Then out of these 10 grams, we extract a given molecule or compound. We are decreasing more and more its mass. It's dry, so it has a long shelf life. It can last very well if a 3-year mission to Mars, back and forth, and it doesn't take much room in the spacecrafts because it's dried, and the capsules are, or the powder, they are very, very easily compressed. A 500 grams jar of an amino acid like taurine might easily cover a daily supplemental dose for 3-4 people for maybe more than 2 years. Also, there is another advantage of nutraceuticals over pharmaceuticals. When astronauts are in space, if something goes wrong, they cannot call 911 and go to the hospital to an emergency room. Pharmaceuticals, yes, they are more powerful than nutraceuticals, but they're also potentially more dangerous. If they cause side effects, I mean, sometimes they might be heavy. So if something goes wrong, I mean, keeping the situation under control in a space capsule millions of kilometers away from Earth with a few people alone, I mean, it's dramatic. On the other hand, to get very sick with high quality controlled GMP produced natural supplements, I mean, people should do something very wrong and dumb with them so they're safer, and their benefits usually are not accompanied by side effects or other unwanted effects. Actually, sometimes a natural supplement or a nutraceutical is accompanied by other positive effects that we also want instead of side effects. For example, lipoic acid, a cheap, very easily available in every health food store supplement. It showed very good properties in improving insulin sensitivity and glucose metabolism. Again, another typical issue of astronauts and of people on Earth, considering how we usually eat. But as a kind of positive side effect, it also showed ability to help with atherosclerosis in stiffening of our arteries. It is also a powerful antioxidant which helps with radiations. I was surprised to hear from Dr. Charles how relevant the problem of radiation in space is. I mean, I knew there were radiations, but not at that level. And also both from the isotropic radiation background of the universe and from the bursts that come from solar flares. Now, radiations damage our DNA. Astronauts are exposed. Radiation produces free radicals in our cells, in their cells. Lipoic acid would help them with the glucose metabolism, insulin levels, free radicals because it's a very good antioxidant. They experience arterial stiffening. Lipoic acid helps. Taurine too, it improves blood flow, besides improving insulin sensitivity and brain neurogenesis in learning and memory areas of the brain. Another beneficial effect of lipoic acid is also that it protects brain from toxins and from damages. And brain is damaged during space mission and prolonged isolation and confinement. So it's all connected. There is a huge science behind nutraceuticals and a lot of benefits. And I'm almost done. I will quickly go through some of the products that I proposed in my report. If any company or university or institution or anybody working on these issues, both for people on Earth or in space, is interested in this, I will be happy to share this material with you. The report was written in a rush in a few days, so there is even much more that can be done and written and researched and designed. This is a 37 pages. One thing is also worth mentioning, because space is mainly a hostile environment. Astronauts are very stressed, and who isn't on Earth too? But their stress is very huge, and they're in danger. It's a dangerous condition, sorry. So to help them with the psychological aspect of their missions, they are allowed to bring comfort foods, and comfort food also helps them to feel like more at home, like to make the hostile environment a little more familiar. The problem is that this comfort food that is appetizing and that make the environment more acceptable and familiar might be considered junk food. I mean, it includes high glycemic index foods, which cause sharp glucose spikes, which affect brain performance and health, and cardiovascular performance and health, candies, chocolate bars, cookies, rice, potatoes. These are all very high glycemic index foods, and other things like that. So one more reason to supplement their diet with nutraceuticals. In this report, I covered some areas of health issues. And let's see, for example, optimization of glucose levels and insulin sensitivity, lipoic acid, taurine, I already mentioned this, and cinnamon extract. Cinnamon is also very effective in improving insulin sensitivity and glucose management. Maybe it's not a coincidence that it also showed very interesting beneficial effects in brain. It helps brain learning, performance. Again, it's very important. Just one piece of advice: if you want to take cinnamon, don't take the common cinnamon that is just sold in food stores as a spice, because that's cinnamon cassia. That's a variety of cinnamon which contains high levels of coumarin. So taken every once in a while on a birthday cake, it's not an issue. But taken on a regular basis, like somebody would to control glucose levels if they have risk of developing type 2 diabetes, or if they have it already, always asking to their doctors, or for other issues, for regular basis, for taking it on a regular basis, that level of coumarin would harm our liver. It's toxic for liver. So if you want to take cinnamon extracts on a daily basis, make sure that if it comes, when you read the label of the product, if it comes from cinnamon cassia, it must be the patent extract called cinnamon rich, TM, registered trademark, because this patent cinnamon extract is purified, so they remove the liposoluble component, which includes the toxic coumarins that are bad for our liver, and they concentrate the beneficial fractions of cinnamon. Or you can take plain cinnamon, even the actual sticks, as long as they are not cinnamon cassia. It's called cinnamon ceylon, Ceylon, also known as cinnamon regina or vera or zelanicum. That can be taken every day. The levels of coumarin are almost irrelevant. Now, cinnamon, taurine. So in the report, there are a lot of studies. For example, taurine promotes cardiovascular health, insulin sensitivity, glucose control, retina protection. It exerts a strong retina protection. Astronauts have problems with their eyes too. If I recall, 20% of them. Electrolyte balance, which is also important for fluids balance, which is important for astronauts. Improved hearing function, heart failure prevention, a blood lipid lowering effect. It's a good compound. Glucose stabilization, there are studies. Acetyl-carnitine, everybody knows carnitine. Acetyl L-carnitine is a special form of carnitine, which is very good for brain. It improves the release of serotonin, dopamine. It favors the adhesion of this neurotransmitter with the receptors, increases choline uptake, acetylcholine synthesis, enhances learning capacity, cognitive functions in aging rats. So this is important, in aging rats. Does it mean that young people wouldn't have any beneficial effect from acetylcarnitine? Maybe a little bit, but maybe less. But again, in space, health seems to undergo an accelerated kind of simulated aging. So see the connection? Beneficial effects for people on Earth with problems, including aging, and simulated similar problems in space. Mitochondrial energy production in cells, antioxidative metabolism. Acetylcarnitine arginate is acetylcarnitine combined with arginine amino acid in the same molecule. It showed even more powerful effects than acetylcarnitine, like 19.5% increase stimulation in the growth of new neurites and nerve growth factor levels, more than 3 times the acetylcarnitine's effect on the second one. Sorry, 19.5% stimulation of the growth of new neurites and more than 3 times stimulation of nerve growth factor compared with acetylcarnitine. Increase in length of neurites, protection of brain cells against toxic substances, increased in the amount of neurotransmitters in neurons, protection of brain cells morphology. And then, there's a lot. Ginkgo biloba, ubiquinol combined with shilajit, I hope the pronunciation is correct, for mitochondrial health and energy production in cells. Magnesium threonate, I already mentioned it. Vinpocetine for blood flow in the brain. Alpha-glyceryl phosphoryl choline, a more effective form of choline, precursor of certain neurotransmitters. And then other compounds that are able to increase BDNF levels besides magnesium L-threonate are again beta-alanine, another amino acid, and also curcumin. It showed this ability. And then finally in the report, I propose some possible new molecules that might be potentially even more effective in achieving these goals. So I guess it will be enough for this video. It's already 29 minutes. I hope you enjoyed it, and I hope you will also be able to experience some beneficial health and performance effects of these natural supplements. But remember, especially if you have already a disease or if you are taking drugs, any kind of medication, always ask to your doctor first before changing your lifestyle, your diet, or taking other products. So thank you for watching, for your patience, and if you have any questions, please feel free to leave a comment in the YouTube video page, and all the best, and live long and healthy.